Welcome to another lesson of transparent physics. This one is on equation manipulation. This is another part of our Toolbox series where we discuss with you skills and concepts that you'll need to succeed starting off in physics. And this is absolutely going to be more of a math lesson than a physics lesson, but I like to say that as a physics teacher, I'm pretty much a part-time math teacher anyway. So let's talk about algebraic manipulation. And aka the dance of the variables, because we're going to move these variables all around, get them moving up and about like a square dance class in gym. I don't know. Did you guys used to learn square dancing in gym? I learned square dancing in gym when I was a kid, do-si-do and stuff like that. It was pretty good stuff. All right. Muy importante. So I don't speak Spanish. I took German actually, but for some reason I really enjoy saying the phrase muy importante. So muy importante is very important, and equation manipulation is very important. When I teach physics in high school, I used to, for many years, the very first day of school, I would say hello to the students, and then I would pass out a quiz testing their ability to manipulate algebraic equations. The argument behind that was to emphasize to my students how important algebraic manipulation is to their success in my class, because nearly every problem is going to have you moving variables around inside of formulas, solving for those, and you're just going to bleed points all year if you don't know how to do this. So it is an essential skill. It will save you time and points, because if you know how to do this, you can get things done fast. So if you're still having questions after this video, I intend to do a follow-up video to show some common mistakes, areas where people tend to trip up when manipulating equations. And if those two videos don't help, please go back to your teacher, check with a friend that's good at this or something. You absolutely need to be able to manipulate formulas in order to succeed in introductory physics. So, and I'll drink a bit of tea for emphasis. All right, let's get down to business. So, manipulating equations is as easy as 1, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3 as needed to get the problem done. Step number 1. Now this is my personal experience, but I have found that at the introductory level, it is best to work your way, what I say, from the outside in. If your variable is buried, if the variable you want to isolate, by meaning isolate, solve for x, let's say, if x is buried deep in the formula, you can't just like reach in and rip x out. You have to eliminate the other variables around it until you get to it. If you're really good at algebra, you don't necessarily need to do this. You can sort of see the whole formula and do what you need to do to appropriately access that variable. But at the introductory level, I would really strongly recommend working away from the outside in. And it can be pretty fun to do that, I personally think. I'll show you what I mean by that. I like to think of it as sort of a spy movie, but we'll talk about that in a moment. Okay, step 2. As you're working your way from the outside in, I recommend that you choose the AU. The AU is the appropriately opposite operation. And I don't know if I need to say much more about this, but the idea is that, if you've got an addition, you need a subtraction. If you've got multiplication, you need division. You need the opposite operation. You need to basically sort of unzip the problem. Button, unbutton. You got to do the opposite thing in order to get it out of there. I'll show you what I mean by that as we go. The AO. This is not an official term. That's just what I call it. The AU. All right. And then finally, the bane of many introductory physics students is they'll maybe get the first 2 steps right, but then they forget to do the same thing on both sides of the equation, or within even the same side of the equation. There's an equal sign for a reason. So if you do something to the left side of the equation, you have to do the same thing to the right side of the equation. Otherwise, it is no longer equal. You've broken the formula. So yeah, we don't want to break formulas. And basically, we just keep doing this process until you've isolated the desired variable. If you're working your way from the outside in, then we sort of just keep on cycling between steps 2 and 3 until we get the formula isolated. So this video, we're just going to show a couple introductory examples of this just to show you how it's done. I will follow this up with a second video, at least that is my intention, showing you common pitfalls and traps that students run into when manipulating formulas. Okay, so a couple quick examples of how this works. Okay, so sample 1. We have A equals B plus C, and we're going to solve for C. So in order to solve for C, what we're looking at here is we want to get rid of B. So I kind of think of this like a spy movie. So C is sort of your target, and but B is hanging out with C. So you got to sort of you got to eliminate B. So if B is added to C. Okay, now in this case, there's not really any working from the outside in because it's pretty much a one-step formula. So working from the outside in, I'll show you what I mean by that as we move in. So we want to get rid of B. In order to get rid of B, since it's B plus C, we want to subtract B because B minus B would get rid of B on this side. So we sort of subtract B, and if we want to subtract B from this side, we have to subtract B from the other side too. We have to subtract B from both sides. If I only subtract B from this side, I've broken the equal sign. So after doing that, I've subtracted B from both sides. So A minus B equals C. And that's it, we're done. We did it. We identified the appropriately opposite operation. If it's B plus C, we subtract B out to do the opposite of the addition. We subtract B out on the other side as well. So if we subtract B from the right, we subtract B from the left, and that's our value. I traditionally tend to then rewrite it so my unknown is on the left. That's me. I just like to write my final answer for consistency so my unknown shows up on the left side. And you can flip left to right on the equal sign as much as you want to. It doesn't change the value at all. Okay. Sample number 2. We have D equals E times F. If you're not familiar with it, we can sometimes just use sort of like a dot in the middle there to show multiplication, or we can just write them right next to each other again, and you can do it any way you want to. So D equals E times F. We want to solve for E. So again, there's not really any working from the outside in because it's just basically a one-step problem on this one. If it's E times F and we want to solve for E, then multiplication, the opposite is division. So I have to divide out F on this side. And if I divide out F on the right, I have to divide out F on the left as well. Whatever I do to one side, I have to do to the other to keep the equal sign valid. And so we have D over F equals E. And again, it's just me. I just tend to like to write it so it's the unknown I'm solving for is on the. Again, if I was doing this on my own instead of in front of an audience, I would have flipped that automatically just in that step without having to write an extra step there. Okay, so the opposite of multiplication is division. So those are hopefully pretty straightforward examples. Let's show you a couple more slightly complicated ones. See how we do. We'll do 2 more, and then we'll call it quits for this video, and we'll let you tune into the next video if you want to see more potential pitfalls you can make when manipulating these formulas. Okay, here is where we have to start worrying about the first thing I said is work your way in from the outside. So we are interested in solving for H. Now H has, it's with I up here. I put parentheses just to clarify it, and there's a J. I can't really go straight for H. I mean, I technically could. Okay, I personally could see what I could do to just start hammering right for H. But generally speaking, at the introductory level, I find it's best for students to just work their way from the outside in, sort of don't. So you're scoping out the compound. You see J here, and then closer to H is I. So maybe J is a little more on the perimeter, and then I is sort of in the command center with H. So we don't go straight in for H. We have to take out J first. So if I want to take out J first, this whole thing is divided by J. So if it's divided by j, then the opposite thing that I need to do is multiply by j. So I'm going to multiply both sides by j. If I multiply by j on the right, I have to multiply by j on the left as well. So then the j's cancel out on the right-hand side. And what I'm going to do is I'm going to automatically flip this. H minus I equals JG. And again, so my preference is having the unknown on the left whenever possible. I just did the auto flip there. So multiplied both sides by j, so it's j times g, and we're left with h minus I. Now I didn't have to write the parentheses. The parentheses are only here to emphasize sort of an order of operations. Once we have this part situated, having the parentheses here is just kind of redundant, but I'll show you what I mean by that. So now it's h minus I, and we are going to get rid of the I. How do we get rid of the I? Well, if it's h minus I, we are going to add I to both sides. The opposite of subtraction is addition. But I need to add I to the other side as well. And I, negative I plus I cancels that out. So we have h equals jg plus I. And that is isolated. What does this mean? Who knows? All right, I just made this formula up. But what we did to begin with is we got rid of j by multiplying both sides by j. And then we got rid of I by adding I to both sides. And now h is by itself. Again, I could have gone in straight for the h, but it just gets messier. But there are multiple ways to go through the same problem. All right, just for example, you guys talk me into it. Let's say another way to do this. What if I looked at this and I said g equals h minus I over j? Let's say you're a little more math savvy and you're like, hey, you know what I could do is I could split this fraction up. I could say, am I still? I'm off camera there. All right, if I split this fraction up, I could say h j minus I j. Okay? And then I could say, well, let me get rid of the second term here. So I'm going to say g, and I'm going to, if it's minus I over j, I'm going to add I over j to this side. And then this is h j. I'm going to add ij to this side. So I'm going to add this term to both sides. So that means these guys drop out. I'm not saying this is an easier approach. I'm just saying that, just as an example, there's more than one way to cross the bridge sometimes. All right. And now what I want to do is I want to solve for h. So if it's h times, or h divided by j, how do I get rid of j? I have to multiply by j. So I have to multiply by j on this side. And the important thing here is to recognize that I have to multiply by j everywhere on the other side. That's the most common mistake that kids will make. They'll multiply just by j here, but they won't multiply by j here. This is a preview of the next video. If you want more tips like this, check out my next video on common mistakes that are made when algebraically manipulating. So j times g is jg. J times I over j is j times I over j. And that's equal to h. And you might ask yourself, well, transparent physics, that's not necessarily the same thing. But it is, because you got a j on the top and a j on the bottom. So we have, I gotta keep track of my screen here. All right, so we have jg plus j over j times I. J over j cancels out, and we are left with the final formula, jg plus I equals h. All right, so we have jg plus I equals h, and look at this. jg plus I equals h. So there are different ways to go about manipulating formulas in many cases. So if I happen to show you an approach of how I get to an answer, and you do a slightly different route, and you get the same answer, that doesn't mean that you made a mistake. There are literally, well, I shouldn't say not always, but often there are different ways to get to the same destination. All right, we'll do one more slightly harder one, and then we'll call it a quits for this one, and maybe we'll see you in the next lesson. So we have k equals L squared minus m over n. We're going to solve for L. So what do we want to do? We want to get L by itself. So minus m over n. We want to get rid of this term first. Now, sometimes what kids will do is they'll get rid of n or they'll get rid of m. Hey, we don't just take this whole term out at the same time. If it's minus m over n, what we can do is we can just subtract that whole term out. So why don't we just say minus m over n? And we'll minus m over n on both sides. So we have k minus m over n equals L squared. That's not our answer, by the way, but we're closer to the answer. Don't even worry about breaking up that fraction. Just move it all over in one chunk. I'm going to just flip this over real quick because that's what I like to do. So L squared equals k minus m over n. This is not our final answer because we are asked to solve for L, not L squared. So if we have an L squared, the issue would be what would be the opposite of squaring. The opposite of squaring would be to take the square root. Okay, so the square root of L squared is just L. And then the square root of this term, generally speaking, I encourage kids to write a plus or minus in front of that. And we can leave it like that. That's it. So the argument here is that if we take the square root of one side, we take the square root of the other side. It's just a safe default in physics. Anytime you're taking the square root like this, recognize that you could have a positive or negative value. It's not positive and negative at the same time, but it could be either or, which in introductory physics occasionally comes into play when you're getting some answers. But when it does come into play, it comes into play in a very cool way, so you don't want to miss out on it. So there we go. That is one last basic example of manipulating formulas. So in all these cases, even though it gets a little more complicated, we are still following the same three steps. It is important to work your way from the outside in. There we are. All right. Work your way from the outside in, choose the appropriately opposite operation, and then do the same thing on both sides of the equation. If you mess up on any of these steps, you could easily end up making a mistake in the whole problem. If you follow all three of those steps, you can still make a mistake, but maybe it'll be a little less frequently. Okay, hey, it was a pleasure talking about this information with you. Hopefully you're a little more confident about manipulating equations now. If you're not, there'll be another video following with more advanced examples, places to watch out for to possible mistakes. And I hope we've made things a little clearer for you on this lesson of transparent physics.